Hello everyone. Welcome to the next video of our lab 4. In the previous video, we completed the bitstream generation, and now in this video, we'll focus on the completing the application code. So we will export the hardware data. Here we will include the bitstream. So after the export, the next step is to launch the SDK. Okay, so in the SDK, we'll start with the Hello World project. So we'll create the new application project. So select the Hello World, and in the Hello World project, in the hello world.c file, I'll copy the code of the lab 3 previous lab where we have used the DMA as well as we have used the FFT implementation of 8.FFT in the PS as well as in the PL. Okay, so I'm going to copy paste the code. Okay, so the code has been copied, and okay, there are certain issues because the DMA name has been changed. So what we'll do first, we'll correct this code to see that if the code is working as per the existing DMA. So in the here you can see that the DMA ID name has been changed. This has happened because we have changed the name of the IP in the your block diagram. So we will use the ACP DMA first to verify the code. So let's go to the hello world.c. So ID, I'll give the ACP ID. So this should be sorted out now. Okay, and the base address is again, I need to give the corresponding ACP DMA base address. So ACP DMA base address for all the call to the read register. Okay, so the code has been compiled properly. So it looks okay. So the status is, I don't know why it is 2 times. So we'll get rid of this. Okay, so this is fine. So usually this variable, it should be defined as the X time. So to get rid of this warning about the seed value. Okay, so code is working fine. So now let's quickly test it on the hardware. Okay, so I'm going to use my remote board. So I'll go to the debug as. Okay, before debug as, I need to modify the BSP setting so that I can visualize the UART input and output on my debug terminal via JTAG. So I'll change it to the core side for the UART input as well as the UART output. This is the important step before you use the remote hardware. Okay, so this is done. Then I'll go to the debug configuration. Go to the system debugger. In the system debugger, I'll use the remote one, reset program. I won't use the cross triggering. In the next video, we will discuss about the cross triggering, though we have enabled it in the hardware. Okay, so then I'll click on apply and then I'll click on debug. Okay, run in the background. Okay, so the debugger is working. So I'll use the JTAG terminal. Okay, so the JTAG terminal here. So let's run the code completely. Okay, so the code is complete, but you can see that the output is not correct. So we need to verify why output is not correct. Okay, so in the code you can see that I have disabled the flush of cache flush, and that is the reason my output is not correct. Okay, so you need to make sure that when you are debugging or trying out a few things, you should look at the code carefully. Okay, so this is the input in the DMA. I'm doing the cache flush, so let's debug it now. So this is the JTAG terminal, and okay, good. So now the outputs are completely matching. So with this, we have verified our previous lab code, which is working on this new hardware which we have generated. Now we need to modify this code to find out the comparison between the HP and ACP port. Okay, so what we are going to do, as usual, we are going to have the two DMA in the hardware. So we'll have two outputs. So for the output of the we'll have two outputs, one for the ACP, and then I'll have another output for the HP port. Okay, so we need to distinguish between the HP and this one. Then these things will remain the same. We'll generate the input. Here also I'll have this for the ACP, and I'll have this for the ACP here. And then I'll copy it for the HP and HP. So this is my time for the HP. So then this is the input is printed. So I'll just avoid this printing just to speed up the processing. Then this is the FFT calculation. So what I'm going to do is that I'll first do the comparison with the comparison between PS and ACP port. Okay, so then I'll calculate the PS calculation on FFT. Then I'll change this one to the ACP IIITD DMA ACP. Okay, I'll use the small letters. Then here the device ID is same. So here I'll add ACP. Okay. Then here it should be the ACP DMA failed. Then FFT input is being passed. Then the DMA here, it should be ACP. So you can see that I'm just trying to change everything to the ACP here. Here also it should be the ACP, output of the ACP1, XDMA, validate range, PL ACP. Then base address is same, base address is done, and this is the ACP. Okay, so what I have done, I have now at this point I have the entire calculation done for the ACP. Now I need to do the same calculation for the this one. for the HP port. So what I'll do, I'll again regenerate the new input because I don't want to use the previous input, because that for that then the cache validation will not be of use. So what I'll do is that I'll generate the new input again here, just to make sure that the game is fair for the ACP as well as the HP port. Okay, so I have generated the new input. Then I'll do the comparison for again for the ACP and HP. This time not the ACP, it should be the PS and the HP. So what I need to do, look at this carefully. I'm not going to recalculate the time for the PS, because I have already calculated the time for the PS and it will remain the same. I can use this one for the averaging, but it is not that important. But I'll calculate the FFT on the PS so that I can compare that with the HP FFT, because I have generated the new input. Then now I'll have a same for the HP. Okay, I can use the same configuration pointer because it's the same DMA, but for the sake of repeatability, I'm using the separate configuration pointer. Now here you can see that the name will change to HP, and this name you will see that you will get it in the xparameter.h file. Okay, so this is what you need to change. Then here also make sure that these changes are done carefully. Everywhere you need to do these changes so that your code will work correctly. So I have made the HP change here. Then here PL, I'll capture the HP start. Then FFT input, no change. Then here also I'll capture the HP, FFT output, HP, okay, input HP. HP, so that is done. Now everywhere I need to change the base address of the HP. So this is very important, HP. So if your code is, you are not getting any output on the display, that means there is some issue in your while one. Your code is stuck in your while loop and there is some issue there. Okay. So now here I'll do the HP. Now I need to do the output comparison. Okay, so I'll do the output comparison separately for the HP as well as for the ACP. So first I'll do it for the ACP here. FL output. I have FL output PL ACP, and here it will be PL ACP. Then here you can see that it is time. I can say that the FPJ ACP, PL ACP, PL ACP, then microsecond. So that is ACP, everything is fine. Okay, so this looks fine. Everything, we have now compared the output of the PS and the corresponding ACP. So we'll print the FFT output on the one. So you can see that the PS and ACP output. So now same thing will repeat for the PS and the HP output. Okay, so make sure the copy paste mistakes are avoided. Okay, so I'll just copy this. Okay, so this is the printf statement for the HP and HP. So HP. So what we can do is that instead of printing the timer output 2 times, we can just print it for the only 1 time. So what I'll do is that I'll remove this print statement here. Okay, so I have printed the processor, then ACP, and then I'll print it for the HP port. So here I have HP, 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 and HP. So all the 3 timing I am printing at the end. So now let's verify this code. Okay, make sure you remove the whatever the errors are there. For example, the pointer redeclarations, some variables are twice defined. So make sure you remove those errors. Okay, so I'll go to the debug mode and I'll test it on the hardware. So click on debug. So make sure that your code is all the variables are properly designed. I had made a mistake here. I used the ACP both. Here you should be, one is ACP and one is HP. So I'll start the JTAG terminal. So this is the JTAG terminal and I'll run the code. So you can see that the code is completed and you can see that the here somehow the HP is being faster than the ACP port. Okay, so this is the result we got. We will verify it in more detail in the next video.